Here's a question where you're asked to identify the sine graph or the transformations of the sine graph. So I take a look at this first one when I've got a C transformation. C, C, they're all C's. So I'm either moving the graph right or moving them left, one of the two. So they do show you cos graphs here, which are different than sine graphs only in where they start, or I guess where they, pardon me, cross axes. But other than that, you can't tell them apart. So some of these graphs might be similar ones, but anyway, let's first take a look at what a sine graph looks like. So sine graph starts here, goes up, down, and finishes in 2 pi, or 6.28. That's a normal sine graph. The normal cos graph, it doesn't start down here, but it starts up at 1. And it goes down and comes back up and finishes right there. And it keeps going, on both sides there. But when I want to look at just one period of a graph or a portion of it, this is what I'm looking at. Same thing with sine. It can keep going. Okay, so let's take a look at just the sine graphs, these two right here. So this is a sine graph that's been moved to the right by pi over 4. So pi is 3.14 and over 4. So I'm calling that maybe about 0.75 or something. So I'm looking for a graph that looks just like this one, except it's been moved over to the right a little bit. No, the middle here is 3.14. So if I'm looking at 0.75, 0.8, something like that, to move over, like this would be 1.57. That's half of pi. So 0.8 has got to be somewhere in there. So I'm looking for a graph that's going to look the same as this. It's just been shifted over a little bit to the right. Okay, so I look at this one now. So I'm starting here. This one looks like it could be it, but it got shifted to the left that amount. This could be this one. This one here, B. This is graph B. I'm betting it's number 3 because that's pretty close. Let's look at C. This is where I normally start. This one started over to the right a little bit. That's got to be it right there. So C, this is graph C. That's got to be number 1. That's what I'm saying. Okay, now let's look at the other ones. Now, let's do blue for cos. Now, I'm looking at this graph, and they're looking awful similar to me. Like, I can't tell the difference between the two. Maybe it's just me, but they look pretty similar. But if it's a cos graph, if it's this graph here, it's the cos graph. This one here, it's the cos graph that's been moved to the right. So and by 0.75, something like that, 0.8. So if it's been moved to the right, because it usually starts here, but this one is starting over here somewhere and then going down. So if it's moved to the right, that would be a minus, so I would be calling it this one 4. So D, I would probably say is number 4. So that leaves this one. If it's the cos graph, usually it starts there. Oh, no. Which is the one I haven't done yet? This one. Okay. So this graph here, if it was the cos graph, it would start there, but this one's starting to the left, so that would be a plus. So it would be this one, number 2. So I'm saying that A is number 2. Did I get all the numbers in? Like I said, these two here, they look pretty well the same to me. The other ones don't look the same. But, okay, so they want to know A, B, C, D. So I'm saying A is number 2, or number 1 is C. 1 is C. Number 2 is A. Yeah. Number 3 is B. Yeah. And 4 is D. Yeah, I'd be picking that one. Okay, hopefully that helps you looking at what those graphs look like. On the exam, I committed to not doing coast graphs. So sorry, there's a few maybe in the homework and in the quizzes. um, but they're not that hard. They're the same as sine graphs. You just have to know that they start in a different spot. But the form, the flow of them is very similar.